in the previous lesson. Yes, what
Well,
is it?
for the AND gate, basically, when you're using the truth table, to get the output, you can multiply. Yes. And then usually it's like a series of arrangement, like when you have two switches and then you have one bulb. And if one is open and one is closed, it will still, the bulb won't light because current is not flowing through the other bulb in order to go to the bulb, through the other switch in order to go to the other bulb. Yes. So it needs both of them to be closed in order for the bulb to light. Yes.
Yeah. So yeah, that's very true. This kind of arrangement is like the arrangement of our gates, these normal gates, that we have the main gate and the Cavagnolo gate. Then result. So when the main gate is closed, Cavagnolo gate is closed. Main gate is closed, but Cavagnolo gate is open. Main gate is open, Cavagnolo gate is closed, and they are both open. So what do you expect as the result? Main gate is closed and Cavagnolo gate is closed. The result will be good. Not so, we shall not have intruders. Do you see that? And what happens if main gate is closed but Cavagnolo gate is open? We shall have intruders. So we put a 0 for intruders. We put a 1 for no intruder. And we put a 0 for intruder. Hope you are following. So that means that what happens if I open the main gate and close the Cavagnolo gate? Yes, we are not using a lot of magic. We're just relating daily life things. Just there's nothing so much abstract here.
Teacher. If one gate is I mean, it will be closed. If one gate is open and if one is closed, it will be closed.
Let us be realistic. If the main gate is closed and the Cavagnolo gate is open, shall we have intruders or no intruders? In fact, let me go back now. Let us just use the key. The key is here. Hope I can. This is our key. 1 is for no intruder, 0 is for intruder. Now, M stands for main gate. K stands for Kabanyolo gate. What happens if main gate and Kabanyolo gate are both closed? Both closed. Now here in our truth table, here we are using for closed and open. It is the result where we are putting a 1 for no intruder, a 0 for intruder. So if both are closed, automatically I expect no intruder. But if one of them is open, an intruder can use a gate where it is open. So I expect a 0. Intruder can come in. Not so? Even here a 0, intruder can come in. And if they are both open, a big 0, intruder can come in. You see that? Now, this result can also be obtained when we use a series arrangement circuit, that for as long as one switch is open, it means no current will flow. Current can only flow if both switches are closed. The same result can be obtained by simply multiplying 1 times 1, 1. 1 times 0, 0. 0 times 1, 0. 0 times 0, 0. So we pick a list from the probability knowledge that and means what? And means intersection. And intersection in probability means we multiply. We do what? We multiply. Whereas O is for union. Union means we add. So the same information has very many approaches through which we can approach it. We can approach it in we can approach this and gate as a circuit, like switches. We can approach it in a way of 2 gates, normal school gates. We can approach it in a way of probability. So that is how simple this work is. Is it okay? And when we say main gate and Kabanyolo gate is the other, many of you don't know it, but this school has another gate, a big one somewhere. But I think you have never reached there. But there is that gate. It is a very big gate. It was constructed last year. So this is the real life application of logic gates. Real life application of logic what? Of logic gates. Is that okay? So we are going to have many applications. So who has joined? Okay, not yet. Now, let us have this question. Let us have this question. Because we have not revised the, okay, the other time we said we have, that is the or and the and. We had also nor. Who remembers the nor? Nor means not or. Nor means not what? The combination of not.
That is you. What's up, Tagenda Congo? No, no meeting IDs.
Nor means the combination of not and or. Who remembers what not means to take us through? Not get means what? Yes. The not get, okay, we use calculators. The not get is one that inverts. Inverting means it gives the opposite of the input. you know, here we have some switches. I don't know if you have ever had, if you have ever seen these switches where two switches operate on one bulb. That one switch can switch on, but you can use another switch to switch off. How many of you have ever seen such a bulb that can be switched on and off by two different switches? Yes? Don't you have them in the dormitory?
Teacher,
Hmm? Do you have such switches in the dormitory? I hope they are there even in. If I'm not mistaken, they should be in class. That it has two switches. One switch can, you can use any of the switches. So meaning that sometime when this, sometime you find a switch when it is open, but when the bulb is on. Meaning that this bulb was switched off using the other switch. You get it, yeah? That for you to switch it off now, using this switch, now you have to close the switch. It will switch off. So that means that now this one acts as an inverter. It inverts that in this way, the on for the switch means switching off the bulb. And the off for the switch means switching on the bulb. Does someone get what I'm trying to say? Yes. Am I saying things that are abstract? Of course, I know someone has just joined. Don't worry. Whoever has just joined, I will create time for you to pick up. Most especially that time when I give an exercise to the rest, I'll bring you back on board. So don't worry. So, but those who have been with us, Jenny was surprised. What did we say about that? Do you remember something like that? Yes? Now people are so quiet. Are you people having supper? Yes. Are you having supper?
No.
No, you are so quiet. Jenny, tell me, what did we say about that kind of symbol? Say, for example, let's say in our truth table, if the input is a 1, what is going to be the output?
The output is going to be 0.
The opposite. And if the input is a 0, the output is a what? Is a 1.
A 1.
The opposite, not so? So that's what this
Yes.
NOT gate does. So if you operate this NOT gate on the OR, the result is NOR. And we saw how that one comes about. I know there's someone who has just joined. Please don't worry. You might be seeing some stars, but we shall pick you from wherever you are. Don't worry. Now, I want to make a point with this one so that they don't miss out also. So we mentioned the other time that, or if I have my inputs A and B, And then the output is output Y is A or what? A or B. So O means the O gate. What is a symbol for O gate? O gate is like that. If this is A, this is B, the result is A or B. And if this A is 1, 0, okay. If A is on and B is on, or A is on, B is off, A is off and this is on and both are off. So what is going to be A or B? Louder and faster. When both are on, what is the result? We just add, yeah? 1 plus 0, 1, 0 plus 1, 0 plus 0. Now, what is how about if I want that A complement? A complement, this is the same as writing A nor B. Combination of not and or. So it reverses this one. A 1 becomes a 0, a 1 becomes a 0, a 0 and a 1. Does someone get that? These are things we looked at the other time. Eh? Should I continue?
Yes, teacher.
Okay. To the one who has just joined, don't worry. These things have a backup. Okay. These are our digital electronics, said logic gates, tables, potential divider, and real life application. So we said digital signals deal with 2 states, low and high. Low can be 0, high can be 1. But we said we can also have true and false, where true represents 1, false represents 0. We can have what and what? On and off. On represents, on is 1 and off is 0. Is that okay? And so on. But we have 2 states. And digital systems are used in computers, smartphones, calculators, and many other everyday devices. So logic gates are basic building blocks of digital circuits. They process binary inputs, 0 or 1, and produce a binary output. So what do we mean by binary output? You remember our output is always either a 0 or a 1. That's why when we add in the OR gate, 1 plus 1, we don't get a 2. Still we get a 1. Because the output must also be binary. Binary means a binary base is a 0 or a 1. A 0 or a 1. So that means that the output should also be a 0 or a 1. So the types of gates that we have, the AND gate, the OR gate, the NOT, the NAND, NOR, XOR, XNOR. I think today we are going to look at the XOR and the XNOR. So that is our target today, and also the potential divider. If we look at those 3, that would be enough dose for today. The ones who have joined today, that means for them we shall need to have a recap before they leave. A recap of what we looked at last time. But for those who were with us last time, At least we are just revising. We are just revising up to here. So the NOT gate, we have looked at it. Now the NAND, we have looked at the NOR. NOR is a combination of NOT and OR, not so. Combination of NOT and what? NOT and OR. How about NAND? NAND is a combination NOT gate and gate. Maybe let me show you how, because sometimes the combination diagram, we've simply said have what we simply say when I have A and then B and then A or B. This is 1 0 0 1 and 0 0. Say A or B, we just add 1 1 and a 0. Now the NOR is we use capital letters. A NOR or B, not OR, not OR. So if OR is a 1, the NOT inverts that 1 into a 0. Now, what is the diagram for that kind of arrangement? We first begin with the A or B. We begin with this one, which gives us an OR gate. So as this one is entered, have this as our input. The output is A or B. Now this output is acted upon by. So we come and we add a NOT gate. Oh, the NOT gate. Now here we have a summary. Here to have it all like that. We have this OR gate, but we have that is 0. That is 0 means that I'm combining the OR gate and the NOT gate. I'm combining this. It means I'm combining this and that symbol. So that is what we get. Now we go to the NAND gate. NAND, we say is the combination of NOT and combination of NOT and. So, but always we begin with AND. We said AND is where if you have A and B, A and B. AB1 0 0 1 1 0 0. A and B. What is the result on A and B? Whom should I pick on to tell me? What is the result on A and B? What is the result here? Now, when I don't mention a name, you're not going to tell me. Ariella, what is the result? Hmm?
I think it's one. One.
Hmm?
Mm.
1,
Mm.
Hmm? Remember, we said if you are stuck in interpreting, we just use the fact of probability that and means multiplication. And means multiplication. If you are stuck with interpreting, when they say A and B, it's like A and B. And this one simply means multiplication in probability. So 1 times 0, 0. 0 times 1, 0. 1 times 1, 1. 0 times 0, you get a 0. Is that okay? So we can borrow that knowledge, but it is important that you also understand what it means. We don't have to simply cram. Most especially when we related it with circuits, with the series arrangement. And was for what? For series arrangement? Yes, was for series arrangement. So is that okay? I realize it fine.
Teacher.
Hmm?
Yes, teacher.
Now tell me what is the other on the last column. What is in the last column?
The last column, the first one is 1.
Mm-hmm.
Then the next one is 1.
Mm-hmm.
Then the next one is 0.
Mm-hmm.
Then the last one is 1.
Jenny, do you agree?
Yes, teacher.
Why?
Because when we are using the NAND gate, we invert the answer we got for AND.
Okay. So we invert the answer we got for AND. That is very true, not so. So what is the symbol for NAND gate? We first write the AND, if that is A and B, but we put a 0. The 0 represents what? The 0 represents the other note that comes in. Is that okay? That's the symbol for NAND gate. All together. Okay, let us learn these other two, then we shall see something else. Let us learn those other two. XOR and XNOR. XOR and XNOR. X means exclusive. The word exclusive, what does that meaning? What do you understand by exclusive? Exclusive. Tell me, you are English people. What does the word exclusive means? Hmm? Yes.
Teacher,
Hmm?
I think it means excluding or not including other things.
Yes. Yes. As simple as that. Excluding or not including.